you are a parent or aspiring parent or guardians that have kids in school that want to major in science, engineering, or finance, you have to share this video to them because some content in this video are not taught in school. In this video, I'll be explaining an advanced aspect of algebra known as algebraic superscripts. In mathematics, algebraic superscripts can be divided into two parts: exponentiation or exponential, or iterated exponentiation. Exponentiation or exponential is the number of times a base number is replicated, while iterated exponentiation is the number of times an exponent or power is replicated. For exponentiation, a raised to power n means this n is called exponent or power, while this is the base number. The whole of this is called exponential. For iterated exponentiation, a tetration n. N means tetration, and a means a base number. Everything together is called iterated exponentiation. The difference between the two is, for instance, if I say a raised to power 2, it means a times a. That is for exponentiation. And here, if we have a tetration 2, it means a raised to power a. That is the difference between them. Here we have a raised to power 3. This means a times a times a. Here we have a tetration 3. It means a raised to power a raised to power a. So the difference between them is what you can see on the board. Let's look at some examples in base number 2 for exponentiation examples and iterated exponentiation examples. For instance, if I say 2 raised to power 1, 2 raised to power 1 is the same thing as 2 in indices. Now, but here it is impossible. 2 tetration 1 is impossible. Impossible. We'll give an impossible value. So if I have 2 raised to power 2, 2 raised to power 2 will give us 2 times 2, which is 4. But here, 2 tetration 2 will give us 2 raised to power 2 also, which will give us 4. So we can see that this and this are the same. But if you have 2 raised to power 3, 2 raised to power 3 is something as 2 times 2 times 2, which is equal to 8. This would not be possible here. Why? Because 2 tetration 3 is something as 2 raised to power 2 raised to power 2. So in this case, this will give us 2 raised to power 4, which will give us 16. So you can see the difference. So if you have 2 raised to power 4, 2 raised to power 4 will give us 2 times 2 times 2 times 2, which will give us 16. You can see 16, 16 here. So 2 tetration 4 here will give us 2 raised to power 2 raised to power 2 raised to power 2. So here we have this to be 2 raised to power 16. Wow, this number is too big. So this will lead to overflow. So it will overflow, definitely. The interesting thing here is this is the same thing as this. So we can easily say 2 tetration 3 is equal to 2 raised to power 4. They are the same because this will give you 16. And this validates the example that we say that a tetration 2 is same thing as a raised to power a. As you can see, this valid with this. So now let's look at some examples in base number 3. For exponentiation examples, we have 3 raised to power 1 to be 3. But for iterated exponentiation, this 3 Tetration 1 is impossible. It will give us an impossible value. Now for 3 raised to the power 2, this will give us 3 times 3, which is equal to 9. And 3 tetration 2 will give us 3 raised to the power 3. This is equal to 27. You can see the difference. So if we have 3 raised to the power 3, this will give us 27 because this is 3 times 3 times 3. But this 3 tertiary 3 will give us 3 raised to the power 27. Oh my God, this number is a very big number. So this is a massive number, a very massive value that this will give us. So this is a way of explaining exponentiation and iterated exponentiation examples. Let's look at some visible types of questions in base 2 that you can be asked under iterated exponentiation. For instance, you can be asked if 2 tetration x tetration 2 is equal to 4, find x. Or you can be asked if 2 tetration x tetration 2 is equal to 16, find x. You can also be asked if 2 tetration x tetration 2 is equal to 2 raised to the power 16, find x, etc. These are possible examples of questions that can be asked under iterated exponentiation. And a visible example that can be asked in base number 3 is if 3 tetration x tetration 2 is equal to 27, find x. If 3 tetration x tetration 2 is equal to 9, this is not possible because this will give us 3 raised to the power 2 and it will be very difficult to solve. But this will give us 3 tetration x tetration 2, which is equal to 3 raised to the power 3, which is the same thing as 3 tetration x tetration 2, which is equal to 3 tetration 2. So this can work. This cannot work this way. You have to convert this to this for you to start solving, so that this can cancel this and this will now be 2 or x tetration 2, which is equal to 2. So from here we can say x raised to the power x is equal to 2, and we can start solving from here. Now let's take a question in the base of 5 to address iterated exponentiation. For instance, if 5 tetration x tetration 2 is equal to 3125, find x. To find x, we're going to convert this to an exponential. This will also be converted to an exponential. Let's go. We say solution 5 tetration x tetration 2 is equal to 5 raised to power 5. So from here, we're going to apply this law. A tetration 2 is equal to a raised to power a for both of them. So here is the same thing as 5 tetration x tetration 2 to be equal to 5 tetration 2. 5 tetration 2 is the same thing as 5 raised to power 5 in exponentiation. So from here, we can see that we have the same base. So we're going to cancel the base and write same base. That is the reason why we cancel. So therefore, x tetration 2 is now equal to 2. So from here, we can convert this to exponentiation. So this will be x raised to power x, which is equal to 2. So this is the same thing as this, following this. So from here, we can apply natural logarithm or common logarithm to move this solution forward. So from here, we can say log x raised to power x is equal to log 2. Taking the solution further from here, we can say this is the same thing as x log x is equal to log 2. And from here, we can add exponential to this by saying this is an exponential log x multiplied by log x, which is equal to log 2. So from here, this is the same thing as log x multiplied by exponential log x, which is equal to log 2. Now, you can see from here that we can apply the Lambert W function. Applying the Lambert W function will only move this solution forward as does. So for Lambert W function, we have W a exponential a to be equal to a. So we're going to apply this to this and move the solution forward. So this will be W log x multiplied by exponential log x, which is equal to W log 2. So this is a way of putting this expression into the function of Lambert, which is W function. So this will now be expressed as log x, which is equal to W log 2. So from here, we can see that we are approaching the solution gradually. This log x is not what we want to find. We have to find the value for x by introducing exponential to both sides as does. So this will be exponential log x, which is equal to exponential W log 2 as does. So from here, we can move the solution further by saying this will now be x, which is equal to exponential W log 2. Because this expression is the same thing as x. I've explained this in my previous video. So this can be taken as the answer to this solution. So if you punch this into a calculator, you have x to be approximately equal to 1.54, and this will be the answer. One important thing you should know about algebraic superscript is that it can be expressed as an exponent of a base or a tetration of a base. That is, a raised to power n is expressed as an exponent, while this is expressed as tetration. This and this are the same thing as superscript. I know you have learned one or two things from this video. Don't forget to like, comment, subscribe, and follow to this channel. Share this video to whoever needs it, and see you in my next video. Bye.